but I want to show you why it's a slow-moving catastrophe with implications that span the globe. And I want you to think of a few solutions to it off the top of your head, because I think you'll be surprised to learn why none of the ones we've come up with so far are easy. I'm Grady, and this is Practical Engineering. I want to clarify that the impacts dams have on sediment movement happen on both sides. Downstream, the impacts are mostly environmental. We think of rivers as carriers of water, it's right there in the definition. But if you've ever seen a river that looks like chocolate milk after a storm, you already know that they are also major movers of sediment. And the natural flow of sediment has important functions in a river system. It transports nutrients throughout the watershed. It creates habitat in riverbeds for fish, amphibians, mammals, reptiles, birds, and a whole host of invertebrates. It fertilizes floodplains, stabilizes riverbanks, and creates deltas and beaches on the coastline that buffer against waves and storms. Robbing the supply of sediment from a river can completely alter the ecosystem downstream from a dam. But if a river is more than just a water carrier, a reservoir is more than just a water collector, and of course I built a model to show how this works. This is my acrylic flume. If you're familiar with the channel, you've probably seen it in action before. I have it tilted up so we can get two types of flow. On the right, you have a stream of fast-moving water to simulate a river, and on the left, I've built up a little dam. These stop logs raise the level of the water, slowing it down to a gentle crawl. And there's some mica powder in the water so you can really see the difference in velocity. Now let's add some sediment. I bought these bags of colored sand, and I'm just gonna dump them in the sump, where my pump is recirculating this water through the flume. And watch what happens in the time lapse. The swift flow of the river carries the sand downstream, but as soon as it transitions into the slow flow of the reservoir, it starts to fall out of suspension. It's a messy process at first. The sand kind of goes all over the place, but slowly you can see it start to form a delta right where the river meets the reservoir. And each batch of sand that I dump into the pump just adds to it. The mass of sediment just slowly fills the reservoir, marching toward the dam. This looks super cool. In fact, I thought it was such a nice representation that I worked with an illustrator to help me make a print of it. We're only going to print a limited run of these, so there's a link to the store down below if you want to pick one up. But even though it looks cool, I want to be clear that it's not a good thing. Some dams are built intentionally to hold sediment back, but in the vast majority of cases, this is an unwanted side effect of impounding water within a river valley. For most reservoirs, the whole point is to store water for controlling floods, generating electricity, drinking, irrigation, cooling power plants, etc. So as sediment displaces more and more of the reservoir volume, the value that reservoir provides goes down. And that's not the only problem it causes.